Hey everybody! So in this video, we're going to be talking about trig functions of any angle. So before, we've talked about trig functions when you're giving a degree or trig functions when you're giving a radian. So for example, you've seen something like this. If I said, find the exact value of sine of 120 degrees. So we would know that this would have to take place in the second quadrant. We'd have to come over here 120 degrees like so. And then we would find the reference angle, and then we would begin filling this out using your special case right triangles. So we've seen examples like that. Now, what we're going to be talking about in this video is what happens if I give you just a random coordinate. So here, let's say that they give us a point 9, -12. And they want us to find all the trig ratios for this coordinate. Now, when I say the trig ratios, we're saying what would sine of theta look like? What would cosine of theta look like? What would tangent be? And then all my reciprocal identities. So we have cosecant, we have secant, and we have cotangent. So I want to know, if I gave you this point, 9, -12, in the coordinate plane, could you identify all 6 of your trig ratios? So let's try this. 9, -12, so this is our x and this is our y. So we know that this is going to be in quadrant 4. Let me rewrite that so it's neater. All right, so I went to the right 9, so here 9, and then I'm going to go down -12. So let's draw this triangle here. Okay, here's my triangle. Now the angle, this reference angle, see over here where you have sine of theta, cosine of theta, tangent of theta, this is sine of a given angle. So the angle is always the angle that is inside the triangle and by the origin. So in order to do this, in order to fill out these trig ratios, I'm going to need all 3 legs of this triangle. So what we're missing is the hypotenuse. So in order to find the hypotenuse of a right triangle, we can do Pythagorean's theorem. So here we'll say 9 squared plus -12 squared. This will give us our hypotenuse. So here we have 81 plus 144 is the hypotenuse squared. 81 plus 144 is 225. And the square root of 225 is 15. All right, now that we have all 3 legs to this right triangle, we can complete all of these trig ratios. So sine, we know, is the opposite leg over the hypotenuse. So here, if I'm basing it off this angle here, the opposite leg is going to be across from that. So that's going to be -12. And then our hypotenuse we just found using Pythagorean's theorem. So this is -12 over 15. And we could simplify this to be -4 over 5. All right, cosine we know is the adjacent over the hypotenuse. So here's my reference angle, theta. The adjacent would be right next to it. So that's going to be 9 over the hypotenuse 15. So 9 over 15 can reduce to be 3 over 5. Tangent is the opposite leg over the adjacent leg. So if I'm looking at theta, the opposite leg would be directly across from it, -12, and then the adjacent leg is 9. So here we have -12 over 9, and this would reduce to be -4/3. Now, cosecant is the reciprocal of sine. So if sine is the opposite over the hypotenuse, cosecant is going to be the reciprocal of that, or that ratio flipped. So it would be the hypotenuse over the opposite. So that's just going to be 15 over negative 12, which this would give us negative 5 over 4. Now, I know the negative is in the denominator, so here you're probably thinking, shouldn't the 4 be negative? But you have to think about basic operations with numbers here. A positive number divided by a negative number is going to yield a negative answer. So as long as you know this ratio of 5 over 4 is negative, it really doesn't matter where you put that. You could put the negative on top or in the bottom or out in front. Secant is the reciprocal of cosine, so it is hypotenuse over the adjacent. So we're going to take the value of cosine here, 3/5, and we're going to flip it, and that gives us 5/3. Cotangent is the reciprocal of tangent. So here, this would be the adjacent over the opposite. So I can take my solution to tangent here, negative 4/3, and flip it and get negative 3/4. So given a point in the coordinate plane, that's how you would find all 6 trigonometric ratios. So let's see if we can do one that is not going to be quite as nice, because here we had all whole numbers. What if we had one that included a radical? So in this problem, let's say our coordinate point is this, -6, -2. So both of these are negative, your x and your y. So this is going to take place in quadrant 3. So in quadrant 3, I'm going to come down here and I'm going to draw my triangle. And then we know our reference angle is always the angle inside the triangle near the origin. And I'll put these values here. So this x distance, -6, goes here. -2 is the y. It's irrelevant that I clearly did not draw this to scale. Don't worry about that. Just as long as you have the triangle, you're good to go. Now, again, in order to find your 6 trigonometric ratios, we're missing the hypotenuse. So here I'm going to say -6 squared plus -2 squared. This is going to give me my hypotenuse. So -6 squared is +36. 2 squared is 4. 36 plus 4 is 40. And now the square root of 40 is going to be the value of my hypotenuse. Now we know that anytime you have a square root, if you can simplify it, we probably want to do that. So the largest perfect square that goes into 40 is 4, and 40 divided by 4 is 10. So if I took the square root of each, the square root of 4 times the square root of 10 gives me the square root of 40. We know what the square root of 4 is. It is 2. So this simplifies to give us 2 root 10. So here we have 2 root 10. Now we're going to use these 3 legs to solve for our missing trig ratios. So let me take all of this and move it just a bit over here to the left. Now I have some room. So let's find sine of theta. So as we said before, sine is going to be the opposite over the hypotenuse, and I'm referencing this angle. So the opposite leg would be -2 over the hypotenuse, which we just found, which is 2 root 10. Now here we're going to have to do some simplifying. So already we have -2 over 2, so we could say this is the same thing as -1 over the square root of 10. What we want to do now is rationalize. So I'll multiply by the square root of 10 over the square root of 10, and this gives me negative root 10 all over 10. So that's the value of sine of theta here. So my next one is going to be cosine theta. So if I come back to my triangle, cosine is adjacent, that's -6, over the hypotenuse, 2 root 10. So here, this would be -6 over 2 root 10. So again, we're going to have to do some simplifying. Negative 2 over 6 is 3. So this is negative 3 over the square root 10. And just like before, we have to rationalize this denominator. So we're going to multiply by root 10 over root 10. Now, if you're wondering why this is okay, like if this is the answer, how on earth could you change it by multiplying by something like this? Well, that's because this right here equals 1. Remember, anything divided by itself is 1. So multiplying by 1 actually doesn't change the value of the solution. So this is going to give us negative 3 root 10 all over 10. Next, we'll do tangent of theta. So if I come back to my triangle here, tangent is opposite over adjacent. So I'm referencing this angle. The opposite leg is negative 2. The adjacent is negative 6. So here I have negative 2 over negative 6. This is really easy to simplify. This is nowhere as difficult as the two prior. So this is going to be positive 1 over 3. Next, I'll find all my reciprocals. So I have cosecant of theta. Now, cosecant of theta is you take whatever answer you got for sine and you flip it. Now, here's why I like to write down every step. This was our simplified solution, negative root 10 all over 10. But the answer we got initially was negative 1 over root 10. Both of these technically are answers. So what I want to do is look at each of them. Which one is going to be easier to flip and get a final solution? This first one, negative 1 over root 10, or this simplified answer, or excuse me, this rationalized answer of negative root 10 over 10. Okay, that answer is going to be this one right here. Because when I flip, I don't have a square root in the denominator like I would if I flip this fraction here. So this is why I like to write down every step. Because sometimes it's easier to look at the earlier part of the problem and flip this versus flipping this one here. So this would be the square root of 10 over negative 1, which this would simplify to give me negative root 10. Right? That was significantly easier than flipping and saying 10 over square root of 10 and then having to rationalize again. So flipping this initial answer saved me from doing a lot of work. So we like that. That's why writing down all your steps is important. Next, I have secant. So I'm going to look at my answers for cosine, and that is here, negative 3 over root 10. It's going to be easier to flip this one than to flip this one here. So I'll say 10 over negative 3. And we know that this negative can come out to the front. So this is negative root 10 all over 3. And then my last value will be cotangent. Cotangent, you take the answer from tangent and you flip it. So this is just going to be 3 over 1. And we know 3 over 1 is 3. So here would my solutions be if in my triangle that I drew, I had a square root. So not too bad. It's just a little bit of work. We just have to make sure that we're rationalizing our solutions. Okay. So if they give you a coordinate point, you know exactly which quadrant you're in. But if we're doing trig functions of any angle, what if they gave you the value of the trig functions and they wanted you to determine what quadrant you're in? So for example, what if here I told you, let's pick a color we're not using. What if I told you that sine of theta is 8 over 17? And then I told you that tangent of theta is less than 0. What if these were the conditions? So like before, I gave you a coordinate point. Well, if you have a coordinate point, this is easy. You know exactly which quadrant this triangle has to be in. It has to be in quadrant 3 because your x and your y is negative. But what if I don't give you a coordinate point? What if I told you, hey, I'm telling you the opposite and the hypotenuse leg. I'm telling you it's 8 over 17. And I'm also telling you that tangent is negative because anything smaller than 0 has to be negative. Okay, where is this going to lie? Well, to do this, we have to think about the quadrant plane and where our values are positive and negative. So in the quadrant plane, you're used to working with x's and y's. So with any coordinate point, you have an x value and a y value. With trig, you want to think about this. Your x values, you're going to think of as cosine, and your y values, you're going to think of as sine. Now, the reason for this can be explained in one of my prior videos, because what they're doing is they're using special right triangles in the unit circle, and they're showing you why cosine is the same value as your x coordinate and y sine is the same value as your y coordinate. But for the sake of this video, we're just going to say that we already know that. So cosine has the same value as x, sine has the same value as y. Well, in quadrant 1, everything's positive, your sine values and your cosine values, because in quadrant 1, your x coordinates and your y coordinates are positive. You learned this back in middle school when you were learning to graph. So in quadrant 1, your x's are positive and your y's are positive. Now, the reason tangent and cotangent are also positive is because we know that tangent of theta is the same thing as sine over cosine, or your y coordinate divided by your x coordinate. So if x's and y's are positive, then here if you had a positive divided by another positive, obviously that gives you a positive answer. So every trig function is positive in quadrant 1. If you're in quadrant 2, here, then you have a negative x and you have a positive y. So if x's are negative, that means cosine is negative. So we're only concerned about what values are positive in quadrant 2. So here, if y is positive, that means sine is positive and its reciprocal, cosine. I'm sorry, y'all. Sine is positive and cosecant is positive. Woo, it's been a long day. So in quadrant 3, tangent and cotangent here are both going to be positive. Now, this can be tricky because you're thinking, whoa, Mr. Phillips, in quadrant 3, I thought everything was negative, your x's and y's. Okay, you're not wrong. X's and y's are negative in quadrant 3, but think about it now. If we know tangent, like right up here, we said it was sine over cosine, or the y value divided by the x value. If we know that y is negative and the x is negative, what's a negative divided by a negative? That's a positive. So in quadrant 3, tangent and cotangent are positive. And then in quadrant 4, you have a positive x and a negative y. So your cosine and secant values are positive. Now, I say all of that to come back to this. You know that with the conditions they gave you, sine of theta is positive. So I need to think, okay, if sine is positive, that means my y values are positive. My y values are only positive in quadrants 1 here and 2 here. So I can't even use 3 and 4. We're not going to use those at all. Tangent is also negative because it's smaller than 0. So if I'm looking at quadrants 1 and 2, I'm trying to think, okay, sine is positive in both, but where is tangent negative? Well, tangent is negative in quadrant 2 because it's positive in quadrant 1. Now, the reason that it's negative here is because we know tangent is y over x. Well, look here, in quadrant 2, it'd be y over negative x. A positive divided by a negative gives you a negative number. So tangent is negative in quadrant 2. This is where my triangle has to go. There's my reference angle. And they've given you side lengths already. They told you sine is 8 over 17. Okay, well, we know that sine is the opposite leg over the hypotenuse. So if I'm looking at this angle here, the opposite leg is going to be 8, and the hypotenuse is going to be 17. Now, using Pythagorean's theorem, we can find the value of this base leg. So I'll come down here and I'll say x squared plus 8 squared should equal 17 squared. So x is going to be the square root of 17 squared minus 8 squared. So this is going to be 15. Now, you had to pay attention to where you are. You're in quadrant 2. We can't forget, we just said your x values are negative in quadrant 2. This would technically be an x value because you started here at the origin. You went left 15 and then up 8. So this really, saying this, sine of theta, 8 over 17, and tangent of theta is less than 0, this is really no different than if I gave you a coordinate point of negative 15, 8. You'd set it up the same way now. Now that I have these values, I'm going to go ahead and solve for all 6 of my trig ratios. Or here, technically, you're only solving for 5 because they give you what sine is. So since we know what sine is, we'll start with cosine. So we'll say, okay, we need to find cosine of theta. We need to find tangent of theta. We need to find cosecant of theta, secant, and cotangent. So let's come and look at our triangle. If we're looking for cosine, cosine is the adjacent over the hypotenuse. So here's my reference angle, the adjacent negative 15 over the hypotenuse 17. So this would give me negative 15 over 17. Tangent, we know, is the opposite over the adjacent. So if I'm looking here at theta, the opposite 8 over the adjacent negative 15. So here I have 8 over negative 15. Again, it doesn't matter where the negative goes, as long as you know the ratio itself is positive. Cosecant. Now, since they've already given you sine, you could just flip this value. If sine is 8 over 17, then cosecant has to be 17 over 8. Secant is going to be the reciprocal of cosine. So here, this would be 17 over negative 15. And then cotangent has to be the reciprocal of tangent. So negative 15 over 8. So these are all of my trig ratios given this initial starting information here. So given just this, sine of theta and tangent theta, I was able to determine the 5 remaining trigonometric ratios. So that was a lot of information in one problem. Let's do another one just like that. So here, what if I gave you these conditions? What if I said cotangent of theta is negative 4, and then I told you that secant of theta is greater than 0. So here's what we have to think. Cotangent is a negative number. So cotangent's negative. Well, cotangent and tangent are positive in quadrants 1 and 3. So here, tangent and cotangent are positive. So I'm going to copy this, and then I'll move it down here as well. So tangent and cotangent are positive in quadrants 1 and 3, which means they're negative in 2 and 4. So 2 here, 4 here. Well, we have to know where we have to draw our triangle. That's where this value comes in. Secant, which is the reciprocal of cosine, is greater than 0. So I need to think, out of quadrants 2 and 4, where is cosine or secant positive? Well, that's going to be here, because in quadrants 2, your x's are negative. In quadrant 4, your x's are positive. So we're going to have to draw this triangle in quadrant 4. Here's my reference angle. Now, they've already given you side lengths. Cotangent is negative 4. Well, let's think about what cotangent is. All right, cotangent is found by the adjacent leg over the opposite. So here it has to be 4 over 1 because 4 divided by 1 is 4. Now, don't go ahead and say, oh, it has to be negative 4 divided by 1. We don't know that yet. We want to put these links on this triangle before we determine which value has to be negative. So the adjacent leg is 4. So if I'm here, this is my adjacent leg, 4, and then my opposite leg is 1. Now that I have the sides labeled, I know that 1 has to be negative because 1 would represent the y value going up and down, not the 4. Don't jump to conclusions here and say, oh, it has to be negative 4, because if you write it here, then you'll set up all your ratios wrong. So let's go ahead and figure out what our hypotenuse is going to be. So we have 4 squared plus negative 1 squared. This is 16 plus 1. So the square root of 17 is going to be the value of my hypotenuse. So no trouble here. Let's go ahead and write this out. We're going to need to know what sine of theta is. So sine is opposite over hypotenuse. So here, opposite over hypotenuse, we have negative 1 over the square root of 17. So what I'm going to do here is rationalize. So this is going to be negative root 17 over 17. Now, when I say rationalize, that's multiplying by 1, and the 1 that I'm multiplying by is going to be the square root of 17 over the square root of 17. You can look previously in this video for that. So here we have cosine of theta, that's adjacent over hypotenuse. So this is 4 over the square root of 17. I'll rationalize and get 4 root 17 all over 17. I'm looking for tangent of theta. So if cotangent is here negative 4, I can just flip that. Or you could just look and say it's the opposite leg over the adjacent leg. So this would be negative 1 over 4. Let's make that the same color as all of our other solutions. I'm sorry, I'm just that way. Things got to be neat. And now I'm looking for cosecant. Now, cosecant, you flip the answer you got for sine. So I'll look back up here. Remember, I like writing everything. Is it going to be easier to flip the first answer, negative 1 over root 17, my unrationalized answer, or would it be easier to flip the rationalized answer? So that's going to be here. It's much easier to flip this. So I'm going to say this is the square root of 17 over negative 1, which gives me negative root 17. And now I'm looking for secant, and I'll flip cosine. So here, this would be the square root of 17 over 4. So that's pretty much a wrap up. That's 2 examples using a coordinate point, 2 examples using trig values. So that's how you would find your trig ratios of any angle. If you have any questions, please be sure to leave those in a comment. Make sure you hit that like and subscribe button. If you have any questions, leave them in the comments, and we'll see you all in the next video.